Hi, I'm Chad Arsenault, and I did water desalination. So that's pretty much the cleaning of water. So we can take any water around the world. It could be salt water, it could be dirty water, and it's a way to create clean drinkable water from this. Did y'all know that only 2% of the Earth's water is fresh drinkable water? And 1.6% of that is locked up in polar ice caps and in glaciers. So really we only have a fraction of the world's water which is able to be freshly used just by dipping a cup in it right now. So, and also 40% of the world's population lives on the coastline. So we're surrounded by tons of water we cannot drink. So the best way to fix this problem is changing that salt water into fresh drinkable water by water desalination. So this would give us the possibility that the world's oceans provide an endless amount of fresh drinking water. So there's multiple different types of plants to do this. One of the most common is the reverse osmosis. So osmosis is the transfer of fresh water to go through a membrane, then it goes into a more mixtures. So fresh water likes to mix with salt water until it reaches equilibrium. A way to reverse this is you bring in the salt water from the ocean. You first clean it so you get all the plant bacteria out, you get the sand and rocks out of the material, then you just put it through the plant. You set one side is going to be the membrane of the seawater, the other side is the fresh water. You put the seawater at a higher pressure, forcing it to osmose through the membrane into the clean water area. And that happens in this tube right here. We have different layers of membranes, and then at different pressures, usually around 1,000 psi, is the pressure you need to get the salt water osmosed to fresh water. After that, it goes to a treatment plant where chlorine and other materials are added to it to make the water taste a little bit better and become more hygienic. Then you ship it out, and it goes into your sink or anything else you can use. Another way is electrolysis. It's where we use electricity to help separate the salt out of the water. Because salt is a polar material, if you have an anode and a cathode, you send water through it, the salt's going to break down and separate to the anode and cathode side, leading the fresh water to come out the center. And we're going to have a brisk come out, or concentrate come out the bottom, which is sent back into the oceans. And when we usually send out this the heavy concentrate of salt back into the oceans, they do this in an area which is fast moving so that it doesn't interrupt the population of plant life and animal life. Usual tests are done within a meter or so. They can't tell that there's an increased amount of salt. And other ways to clean your water is solar and freezing. Freezing kind of really surprised me. When water freezes, the salt doesn't freeze in it. So when you get to the slurry stage, you go past that and you can actually wash the salt right off the ice. You melt the ice and it's fresh clean water. So what I'm really be talking about is the thermal distilling of water. And one of the main effects, or one key property that plants use, would be the multi-effect distillation. This really is a low energy source. They use less than 1 kilowatt per meter cubed, which is a lot. I found that the reverse osmosis uses around 3 kilowatt per meter squared, so that's a lot more power, and this is actually using heat to distill. So to go through it a little bit, we have our boiler, per se, and it sends water down, and it cleans it, and it goes into our fresh water side. We use the salt water discharge. So for fresh salt water coming in is going to go over the boiling heat exchanger. Water is going to build up the bottom, the salt water. It's going to evaporate, sending it into these tubes. As more fresh water is coming down, it'll cool this amount of salt water and also send it into the tubes. So we have multiple stages of heat exchangers in a boiler system. So as you're sending the water through, it's going to get onto the heat exchangers. It's going to evaporate. The evaporation is going to go through the next set of heat exchanger and cool down and come out the bottom as fresh clean water. While in the bottom of these cylinders, the concentrate is going to be taken out and sent through and discharged later on. So it's just a repeating cycle as we clean the water and send it through, more water can be added. A large system like this is usually a plant about the size of a football stadium. It can clean up to 68,000 cubic meters a day. So that's a lot of water that they're being able to clean with this short amount of energy. Another great opportunity with this kind of system is these boilers or evaporators really don't have to operate at high temperatures. Everything is happening under 70 degrees Celsius. The next system that they use is the mechanical vapor compression. To go over it, we have this large container full of salt water. We're heating the salt water, making it boil. This boil is going through a route system and to a pump. This pump's pushing out the steam, which goes back through at the lower phase of the boiling water. This acts as a heat exchanger. It cools down the steam while also heating up the tank of salt water. Thus, we're giving out our fresh distilled water as more salt water is added. And this process is used in multiple layers. So you would have one of these added to each other. So we're going to have multiple, as you see in this chain right here. So each step, you're getting cleaner and cleaner water until the end result comes out fresh. This uses a little bit more power, 1.5 kilowatt per meter cube. So it's about there with the same as the previous mechanism, but a little bit less efficient. But they find that 98% of wastewater cleans up to 98% of the water, leaving the rest of the waste. And this is a small unit, like an individual one like this, clean up to 3,000 cubic meters per day. So when you add them up, 8 or 9, 10, you get a lot of clean water from that. Here's some of the equations and data I found. Some of the important stuff that you have to think about with the MED, the overall heat coefficient is pretty important. With each step of the boiler and coolant, you need to know what the overall heat is going to be, and that will show you how much energy you have to put into the system. And then we can also calculate from that our flow mass. Going to the vapor compressor, we want to know the overall heat loss that we're going to find. So here's a list of data from the vapor compressor. As you can see from each step going down, our temperatures are generally going down. So showing that it's more and more effective each round. And I'm going to show you all a quick little video. It's new technology coming out, which will revolutionize how we drill oil and get water out of it. 80% of what comes out of the ground when you're drilling is not just oil, it's actually really dirty water. And if we find a way to clean up that water, you will have two resources you can sell, both the oil and the clean drinkable water.
Same technique we're using here today, which is called thermal distillation. That's where we evaporate water and then recondense it. If you think about what happens right now in the world's oceans, the sun is beating down and it's evaporating